symmetric Euler sums formula. So basically in this video we will add these two sums and then get a nice result in terms of zeta function, which is over here. You might have noticed that this is just the Euler sum for r equals to 1. Yeah, basically if it was s p r q, this is sum from k equals to 1 to infinity of s k to the order p whole power r by k to the power q. Yeah, that's why when r is 1 we get this required sum, and we are adding two different kind of sums where p and q are swapped. Yeah, so the sum of the symmetric sum is also symmetric result, and this is pretty good. So let's derive that in this video. So let's begin with simplifying the sums by writing as k to the order p as its infinite sum, as its sum. We have sum from k equals to 1 to infinity of 1 by k to the power q. Yeah, and then sum from I equals to 1 to k of 1 by I to the power p. Yes, similarly we have sum from k equals to 1 to infinity of 1 by k to the power p, and then sum from I equals to 1 to k of 1 by I to the power q. Okay, so we have these two sums. Yeah, now what we can try to do is, first of all, let me write it as double sum, and then I will tell you what we can try to do next. 1 by I to the power p k to the power q plus sum from k equals to 1 to infinity sum from I equals to 1 to k 1 by I to the power q k to the power p. Okay, so over here both of them go from basically 1 to k, 1 to k. Yeah, now let us try to change the order of sum in one of the sums, so that this will basically go from k to infinity and not just 1 to k. Yeah, and that will make things simpler in some way, because 1 to k and k to infinity can be added. Yeah, we will see that in some time. If you swap the sum, we basically have sum from I equals to 1 to infinity and sum from k equals to I to infinity. Yes, 1 by I to the power p k to the power q plus sum from, let's write as it is, k equals to 1 to infinity sum from I equals to 1 to k of 1 by I to the power q k to the power p. Yes, now over here, since I and k are just dummy variables, let us swap I and k with each other. Yeah, and the sum will still be same. Yeah, just write I in terms of k place of k and k in terms of place of I. That will not really matter, because these are just dummy variable and they can be replaced by anything. Yeah, and if we do that, because over here it goes from 1 to k, and over here that will go from k to infinity, so we can add them. Yeah, that will make things simpler. So sum from k equals to 1 to infinity sum from I equals to k to infinity. Now 1 by, this is k to the power p I to the power q plus sum from k equals to 1 to infinity sum from I equals to 1 to k of 1 by I to the power q, I to the power q k to the power p. Yes, now let us try to take the sum from k equals to 1 to infinity of 1 by k to the power p as common. If we take sum from k equals to 1 to infinity of 1 by k to the power p as common, here we have sum from I equals to k to infinity of 1 by I to the power q, and over here we have sum from I equals to 1 to k of 1 by, okay, this is also I to the power q. Yes, yes. So now over here this sum can be added, but here notice that if it was from 1 to k minus 1 and then k to infinity, then like there will be no gaps or no over terms that are added. Yeah, but basically over here 1 by k to the power q is added in this sum as well and in this one as well. So basically 1 by k to the power q is one excessive term, but others they just go line by line. Yeah. So basically what I want to say is we can write this sum as sum from I equals to 1 to infinity of 1 by I to the power q. Yes, and plus there is one extra term, that is 1 by k to the power q. Yes. Now let us multiply these two things, so we get sum from k equals to 1 to infinity of 1 by k to the power p, sum from I equals to 1 to infinity of 1 by I to the power q, and then plus sum from k equals to 1 to infinity of 1 by k to the power p plus q. Yes. Okay, so now this is just Riemann zeta of p, this is just Riemann zeta of q, plus this is Riemann zeta of p plus q. Yes. And yeah, that is the required result that we need to prove, isn't it? Yeah, this is Riemann zeta of p, Riemann zeta of q plus Riemann zeta of p plus q. And so we have really proved this symmetric sum identity of the Euler sums for r equals to 1. The flow was, we just changed the order of sum at first, yeah, and then changed the variables I and k, and now we saw that these two sums actually add up to go from 1 to infinity with one extra term, and extra term multiplies to give a new sum, and that gives us the required result. So that was it. It was pretty nice, simpler and interesting. Hope you enjoyed the video. Thanks for watching and look forward to seeing in the upcoming videos too.